Well, I did some voiceover PowerPoints for chapter 19 just to kind of adhere to our lecture schedule. And I can't remember if I did 3 or 4 of those. And so I think we're caught up. We were supposed to get through respiratory system today. And again, I'm just going to try to stick with the schedule. So after we come back from break, we have blood, chapter 14, and then cardiovascular, and finally lymphatic before we wrap up the semester. So after we come back from break, it looks to me like we have 1, 2, 3, 4 weeks. And then the next Monday, the 11th, is our last day of the semester before technically final exams would begin. So, you know, it's gonna be down to the wire here before you know it. I will no doubt use some of the break to get a start on the blood chapter. So if you are so inclined and you want to look ahead, I'll try to have some stuff, voiceover PowerPoints for chapter 14 done sometime this week or next week. Okay, I don't see any point in waiting. It's been 10 minutes since we started the meeting, technically, so.
I think this was our first meeting that started at 1:15. I wonder if that's influencing it, you know?
Yeah, true. I just kind of went with the suggestion of the group that felt, you know, that meeting at the regular time would be easiest to remember. So maybe we have 33 people that aren't remembering. I don't know.
Right, yes.
But I tried to be as clear in my email, but I'll tell you guys, I learned how to go into Blackboard and look at how many people have viewed the PowerPoint voiceovers, and maybe I'm just not understanding the data, but my sense is that there are a lot of people that have not made use of those. Because I can actually, I'm not trying to put anybody on the spot or anything, but I can track each individual student to see how many times they've accessed and looked at some of this stuff. I'm not going to start pointing blame or anything, but if people start not doing well on quizzes and such, I might strongly suggest that maybe you go into Blackboard and look at the PowerPoints, voiceovers or whatever. So you really need to look at those. At least check them out anyway. Whether you use them or not is kind of up to you. So I guess I'll open the floor for questions regarding the muscular system or respiratory, or you know, we can also talk about lab stuff as well. No question, that would be fine with me. But maybe we open the lecture topics first, and then we can do lab after that. So
I have a question for the first part of chapter 19, the respiratory system.
Yeah.
And towards the end, there was the clinical applications, and they discussed, you know, the disorders that impair gas exchange, you know, like ammonia and tuberculosis.
Yeah.
Could you possibly, just because I'm curious, could you describe how COVID-19 impairs the physiology of the lungs as well?
You know, I was just talking to my wife about that. She said, "Are you doing a lecture on COVID-19?" I said, "You know, I should, but I haven't done the research. So I cannot speak to it more than what little I know, having just read a few things. I'm happy to probably put something together. I should just do that for both the micro class and for you guys. So what did the epidemiologist we had in before we went online, he was talking about how, again, it's impacting the respiratory tract. And of course, a lot of these people that are sort of older but have underlying health conditions are dying as a result of pneumonia. setting in. But I just seriously and honestly cannot tell you specifically what the etiology of COVID-19 is. I'll do some
Mhm.
research on that and let you know. It's something
Okay.
I've been wanting to do. I think it's obviously a pertinent thing to do, especially since we're in respiratory system.
Mhm.
I was watching the news last night, and they were interviewing a physician from the Bronx, I think, or Queens. And this poor ER doctor or internist who'd been there for a number of years was just ran ragged, as they all are, having worked in all these grueling 13-hour shifts and all that stuff. And she was saying how people come in, speaking, talking in the morning, and they're on a ventilator later that day. And the average time that these patients are on ventilators, she said, was 2 weeks. Ordinarily, it's not nearly that long.
Mhm.
And of course, the concern is that we're going to run out of ventilators, which has been in the news the last week or two, and how they're actually going to perhaps need to split the tubes so that one ventilator can be used for 2 patients. And there's a lot of downsides to that too, because you can't control sometimes the needed ventilation rate and all that stuff, because what are the odds of 2 patients having the same needs? I mean, I'm sure that if they come to that, they're going to try to do that, but
Mhm.
it makes it really super tough. So let me put that down as a to-do list. Other questions related to muscle or respiratory? Hi, Michaela. Hi, Kristen. They've joined us a little late. So we're just opening the floor for lecture questions, either respiratory or muscular, and then we can talk about lab a little bit later if you want.
Could you maybe discuss the part where it shows the controlled breathing and the pons and the medulla oblongata? Could you go over that, review it with me, and maybe tell me what activates what? Does the pons activate the medulla, or does the medulla activate the pons first?
Okay, let me see if I can get to my where is my PowerPoint here? I'm going to do a better job of organizing these. That's not what I want. I'm looking for the original chapter PowerPoint. I've got these divided up into segments that I recorded, so I'm having a hard time finding the original here. Maybe this is it down here. There we go. Okay. I'm not going to have you necessarily worry about the can you guys see the screen okay?
Mm-hmm.
The PowerPoint slide, okay. By the way, before I go on, let me see if I can somehow activate the chat in case there are questions that people have. So you guys can see respiratory areas PowerPoint slide.
As of right now, it's showing, let me see. I see the Zoom meeting
Okay.
schedule.
Okay, hang on. Let's see if I can. How do I get rid of this here? New share. Okay, how about
There
now?
we go. Yeah, I see it.
And it just went to control of breathing?
Mm-hmm.
Okay, okay, great. How do I turn on the chat here? In case anybody is writing while we're talking, there should be a way to do that. How do I do that? Okay, I think I got the, do you see the group chat box here too?
Let's see.
That I'm moving around? No?
No, I don't.
Okay.
Mm-mm.
All right, so somebody type something in the chat line, would you? Hi or something like that. Just so I know that it's coming through. Okay, thank you. Just in case people want to type stuff, and I won't miss that comment. So the as you can see, the pons and medulla are where we house those two primary respiratory regions, which regulate both frequency of breathing and also how deeply one breathes. And when I first started using this textbook, the way that they are teaching this today is different than what they taught or what they had in the book, say 10 plus years ago. So my sense is that we're not positive in terms of exactly how these centers sort of work. When we know how they work, but there's a lot we don't know, let's put it that way. And that's kind of the impression that I got when I started, again, looking at the changes that they implemented with the last edition or so. So this is the latest schematic there, 1929 in your book on 752. And it appears that the pons is obviously communicating with the respiratory groups in the medulla. And the dorsal respiratory group communicating directly with the ventral. I don't think you really need to, get into a lot of specificity in terms of exactly what group communicates with what group, but just to understand that both work in concert with one another, that the pons seems to have a bit of a inhibitory impact on exactly how deeply one breathes. So that's kind of what this first bullet talks about, limits duration of each inspiration. And exactly how that happens, I can't tell you, other than there is that communication between pons and medulla. Ventral group kind of having this fundamental impact on rhythm, which is another way of saying rate of breathing or frequency of breathing. And they mentioned here, dorsal respiratory group integrates sensory information and modifies the ventral respiratory group. So what they should probably have here, if they wanted to get technical about it, is some sensory input coming in. They probably just didn't want to muddy the waters here any more than they had to, but
Right.
I would just understand dorsal kind of integrating and accepting sensory information, directly influencing ventral, with ventral impacting, again, basic frequency of breathing, and probably duration, and duration, how deeply one breathes. And the pons here, somehow limiting the duration, how deeply one breathes. And that's the only thing I would have you kind of get out of this slide. the physiology again, I don't know that we know exactly all of the nitty-gritty of it.
And is that what the PONS mostly controls, though? Just the respiratory system?
Gosh, it's been a long time since I've taught ANP2, nervous system.
Oh, okay.
That's a great question, and I don't know off the top of my head the answer to that. Let me just look real quick. I can tell you probably in about 2 minutes or less. Okay, PONS. Relay sensory information from peripheral nerves to higher brain centers. Other nuclei may function with the centers of the medulla to control breathing. Now, isn't this interesting? Other nuclei may function with the centers of the medulla. Again, back to this idea that I don't think they fully understand all of the physiology. So given its strategic location, the pons and the medulla, part of that brainstem, it makes sense that any sensory information coming up into the cerebrum, which is all this is the right cerebral hemisphere, and the left is of course removed, and this corpus callosum connects the two. So any incoming sensory is going to have to pass through medulla pons on its way up. So these carry sensory information up, and they're also going to carry motor information down. And that kind of makes sense. It's sort of like a bridge between the cerebral hemispheres and the spinal cord. But physiologically, other than relaying the sensory information up toward the higher centers, it appears that the other major function is in respiration. Yeah.
Respiration. Okay.
I don't see any other significant function that the book describes. It's interesting because it is a fairly sizable part of the brainstem. I mean, it's pretty big.
I know.
It just could be that the physiology of respiration and so forth is a very complex process. I mean, I'm just kind of hypothesizing here as to why it's such a large piece of brain tissue.
Mm-hmm.
Yeah, interesting.
It is.
Yeah. Okay, other topics. Akila, Kristen, Stephanie, anything you want to ask about? Again, my thinking is the voiceover PowerPoints would be something to look at before class, so that if there are parts of those that you're having trouble with, we can talk about those.
The chemoreceptors.
Mm-hmm.
What chemicals specifically is it again that they receive information from?
Okay, so let's go to that slide. It sort of depends upon what chemoreceptors we're talking about, because we have the central and peripheral groups. So in the case of the central chemoreceptors, again located in the medulla, they're monitoring hydrogen ion levels, mostly in the cerebrospinal fluid. Now, we haven't really gotten into talking about cerebrospinal fluid much, other than you should know that this is a fluid that basically circulates around and inside of the brain spinal cord. And in your textbook, they make mention, if I can find the quote here. The central chemoreceptors also respond to changes in blood pH, but only indirectly, because hydrogen ions do not easily cross the blood-brain barrier, and therefore do not have direct access to this area. So again, this is monitoring pH of cerebrospinal fluid.
Spinal fluid, okay.
Yeah. Now, I pose a question here. What is the relationship between hydrogen ion level and pH?
Goes up and down.
So-
If the hydrogen levels go up, the pH levels go down. Is that right?
Yes,
Okay.
that's right. Inverse. Very good. Yep. As the hydrogen ion concentration increases, the pH drops. Absolutely right. Now, it mentions here also that carbon dioxide, which you know is a waste product of cells, right? It, unlike hydrogen ions, can cross this blood-brain barrier. So what ends up happening here is that the CO2 level in the blood is pretty much the same CO2 level as in the cerebrospinal fluid. So when we look at this equation that we'll talk about in just a minute, think of this CO2 as in the cerebrospinal fluid. It's also found in the blood, and they're about the same concentration. They're in equilibrium. So in the brain, in the cerebrospinal fluid surrounding the brain, we have this chemical reaction which actually occurs in the blood as well. And this was a reaction that you should be kind of familiar with. It basically says CO2 plus water in the presence of a particular enzyme here called carbonic anhydrase produces an acid called carbonic acid. So that's what this is, H2CO3. And this in turn dissociates into hydrogen ions and bicarbonate ions. And I want to draw your attention again to the hydrogen ions because we know that's what influences pH, doesn't it? As you just mentioned a moment ago. So if the CO2 level in the cerebrospinal fluid goes up, what will happen to the pH in the cerebrospinal fluid?
Go down.
Correct. Because as we drive this reaction from left to right, as this increases, this increases. As this goes up, as you said, Lauren, pH goes down. Absolutely right. Okay. So this has implications. If you think about, for example, what happens when you are running a race or outside doing something very physically exerting, you know that your respiratory rate goes up, right? We can all picture that process. Why does it go up? Well, it goes up because the blood pH and the cerebrospinal fluid pH are going down. So this directly influences the respiratory areas of the brain to increase their motor impulses to respiratory muscles. So there's more nervous stimulation of the diaphragm and the external intercostal muscles, which you know are involved in inspiration. Which it kind of just intuitively makes sense if you just think a little bit about it. As you're exercising, running a race, always think of that. What's happening is the blood CO2 level and the cerebrospinal fluid levels are going up. The CO2 levels are going up. That causes hydrogen ion levels to go up. That causes pH to drop. That pH drop is ultimately what triggers the respiratory centers, primarily the medulla, and it in turn will send motor impulses down to the muscles more frequently, and the result is a faster breathing rate. And in all likelihood, what else will happen to your breathing maybe? You might not only breathe faster, but you might breathe more deeply. maybe. All in an effort to do what?
To supply oxygen to your cells.
Well,
Right.
that's one reason, that's true. But what's causing the increased respiration here? Ultimately, it was the increase in what?
Physical excursion. The
CO2.
intensity
The CO2.
of the CO2.
This is what you see my CO2 and my thing going around it?
Mm-hmm.
Yeah. So this is what started the whole ball rolling here. So you want to do what to your CO2 levels as you breathe more deeply and more frequently?
You want them to go up.
No.
Right? Or down, I'm sorry. You want them to go down.
Yeah, you want to breathe more frequently, more deeply, so you can drive the CO2 levels down.
Right.
If this drops, what's going to happen to hydrogen ion levels?
Drops.
Right. What's going to happen to pH?
Goes up.
Go
Right.
up.
What do we call that process? Starts with an H. Homeostasis.
Homeostasis, yes.
Right? You want to maintain a stable blood pH, a stable cerebrospinal fluid pH, and if pH goes up, you want to bring it down. If it goes down, you want to bring it up. It's just classic negative feedback. Homeostasis, just another example of it.
Mm-hmm.
This, of course, influencing the respiratory system. So it's the respiratory system that can ultimately affect not only oxygen absorption, you're absolutely right about that, but just as importantly is not letting this CO2 level get it thrown out of whack either.
Mm-hmm.
Yeah, because we talk about respiratory alkalosis or respiratory acidosis. So you believe it or not, you can hyperventilate to the point where you drive the CO2 level so low and the pH so high that becomes a problem to an individual. You went to what's called respiratory alkalosis. The pH gets too high. Blood pH is somewhere around 7.35 to 7.45, 7.45. It's a very narrow window. So you let it go too high or too low, that's not good.
And when you're hyperventilating, for how long you're doing it for, would you potentially pass out and then your body would go back to that equilibrium?
Yeah.
Right? Okay.
Because if you pass out, what's going to happen to your respirations probably?
Slow down.
Yeah, and if that slows down, what's going to happen to your CO2 levels? Compared to what they were when you're hyperventilating, they're going to go where? Up. And then the pH will go down to where it needs to be. See, it's very logical if you just think about it.
Right, yeah.
So somebody who's hyperventilating, what they'll often give them is a paper bag to breathe into. Why?
To increase the CO2 level?
Yeah, you're rebreathing in your CO2 that you're expiring in the bag. Yeah. Does that make sense?
Yeah.
Yeah. That's why they sometimes do that. Okay, so that's the central chemoreceptors. Then we also have what are called peripheral chemoreceptors. And these peripheral chemoreceptors are located in the arch of the aorta, shown here, and also up in what are referred to as the carotid bodies of the carotid sinuses. The carotid arteries come off the aorta and they feed blood up into your head and neck and brain. So they're really important. These are the arteries that we were trying not to cut when we did our tracheostomy. Remember reading about that? Because blood's pumped under a high pressure here and it's coming right off the aorta where it's really under high pressure. So these blood vessels are carrying super oxygenated blood. It has just come from the lungs, taken to the heart, and the heart's delivering it to the rest of the body. So these peripheral chemoreceptors, unlike the central, which were monitoring blood pH, right? These are monitoring blood oxygen levels, PO2, partial pressure oxygen. Okay, so that's an important distinction to make. Central chemoreceptors monitoring the pH, and peripheral monitoring blood oxygen. And note that these particular receptors in the aortic arch and in the carotid sinuses here will only become stimulated and send impulses to the respiratory center if the blood oxygen level gets really, really low. And so how low must it get before these chemoreceptors will become stimulated? The book says that the oxygen levels have to get to 50% or lower than normal. Now that is an extremely low PO2 for blood. I'm not saying it can't get there, it can, but it would have to be some sort of a traumatic respiratory event, like the lungs begin to shut down or there's really diminished lung function. But if that happens, then these chemoreceptors will kick in, affect the respiratory center, and cause it to send more impulses to the respiratory muscles, and you'll end up breathing more deeply, more quickly, in an effort to bring the O2 level up. So I think of this as sort of a, I won't say redundancy built in, but it doesn't, these chemoreceptors don't get stimulated nearly as much as the central chemoreceptors probably do, because it would take an extraordinary drop in blood O2 before they would respond. But if it does get low, they will respond. They will help you breathe quicker and more deeply.
What situations would cause this to go so low?
Again, I would say like emphysema, any of the lung disorders that they talk about there in the book, emphysema, chronic pulmonary obstruction, tuberculosis, anything that's impacting the function of the alveoli and gas exchange certainly would contribute to this. I'm sure there are other things too.
Okay.
Good question.
This is off top, or this is going back to the first of this chapter, or the beginning on the video.
Sure.
The vocal cords, the true and false.
Yeah.
So this is just curiosity. When you show the image of the true vocal cords, and it's showing how that affects, you know, the voice, and now this is my question: is that if vocal cords are more symmetrical or asymmetrical, does that affect, you know, someone's voice as well? Is that what, like the shape of them, does that contribute to, you know, someone's singing abilities, or, you know?
When you say asymmetrical, what do you mean by that?
Like if they're not as balanced, or if there's like a deviation on one side, could it cause?
Certainly, I don't know that they're typically asymmetrical. I mean, in most people, they're going to be.
Oh, are they? Okay.
Well, I mean, I've never heard of asymmetrical vocal cords. I'm not sure. Where did you get that concept?
It came. I just was thinking it when I saw the image. I was wondering if like if some people have more symmetrical vocal cords, or if like the shape of them causes any alterations to someone's voice.
Well, you know, that's a who would you ask? Who could answer that question? Of a voice teacher, what's a physician that studies the larynx? I don't know. A laryngophysiologist.
Okay. Yeah.
It's interesting how we all have our own unique sounds that we make, whether we're talking or singing. So it is interesting, isn't it, when you just think about that, and how some people have the ability to reach the lower notes, a baritone, let's say, or a soprano who can sing high notes. Some of that probably goes into training, I'm sure, but maybe there's some inherent abilities that the individual has as well that is just as important as the training end of it, certainly.
Right.
This would be an interesting topic for like disorders of the vocal cords. You know, I just came to my mind as we're talking about this. Because who was it? Who was the singer that was popular a couple of years ago? What's her name, from England? You know what I'm talking about.
Yeah, there's a few of them though.
No. She had all these hits. Adele. Remember Adele? She had to take like a year off, and did she have surgery on her vocal cords? Yeah, and it was kind of like gonna derail her career. She was kind of concerned whether she could come back and have the same voice, and of course she did. It's interesting. I don't know what that would involve, in terms of surgery, what do you do? What can you
Right.
do? Certainly resting them, you all hear about. If a person has laryngitis, just don't talk and the inflammation will go down. But yeah, I'm not sure. I'm not sure about your question. It's an interesting question.
Thank you.
Um,
The tracheostomy
Yeah.
that's performed when you're unable to do the Heimlich,
Yeah.
or when the Heimlich isn't successful.
Right.
So you mentioned that like a medical professional would go ahead and make that incision, and so I see that. Yes, I see the incision there. If, say for instance, if you had to do this at home, would you? It would be in this section here, right?
It's
Is
so-
that
it's-
something?
It's so funny that you talk about this or ask that question, because if I were in class teaching you guys this lesson, I have a story that I tell, and we kind of go through and talk about this kind of stuff, and it's kind of funny. But yeah, if you feel where your Adam's apple is, and go just inferior to that,
Mm-hmm.
you can feel sort of this little notch right above the manubrium of the sternum. Oops, sorry. And that's the location where that incision would be made. And the story that I start out with is you're out to dinner and the person next to you sitting at the table suddenly stands up and clutches her throat, and she turns blue and she falls over, and we go through the whole thing. And what are you going to do? Well, you try the Heimlich maneuver, or you stand on her and jump up and down and try to dislodge the shrimp. That doesn't work. You go in with the finger sweep and all that, can't get it. And all you got is a steak knife with A1 on it, and so you wipe that off, and make it kind of a funny story. But the reality is, you've got to make sure when you do make that cut, if you end up making that cut, that it's number one, a central incision, because again, you've got jugular veins and carotid arteries coming up here too.
Right.
You go a little right or left to center, you might as well just run, because the guy's going to bleed out. Yeah.
Right.
So there's the skin and musculature is very thin right there, so it doesn't take long before you would actually hit this cartilaginous trachea. And then once you make that little incision, you've got to somehow keep that open, because it's going to close right up. It's cartilaginous here. So run to the bar and grab a bunch of straws, or grab your Bic pen and pull out the pen, right? And then you can stick the plastic down in. So you have some sort of an opening by which the air can get in and out. Now, a paramedic is going to have some device that they're going to stick in there, tube of some sort. But when you do this at home tonight, make sure you got something better than a straw.
You never know.
You never know. We got talking last semester about, well, now if a person did that at a restaurant, would the Good Samaritan law protect them from being sued if the guy died, or the guy said, well, wait, I don't want you doing that to me years later?
That's a good question, right?
I mean, I don't know. If you tried to save them and they died, in today's litigating world, it almost, you can see why people would not want to step forward for fear of that, maybe. I don't know.
Right.
But if you do this, you better have some semblance of what you're doing. And I'm not saying I could do it either, but I would know about where to cut, I think. I'd call 911 first.
Right. Yes.
Yeah, but if you're down in Duke Center, PA, there's not good reception, so you better grab that steak knife. Other topics, questions? We can talk about lab stuff if you want to as well.
I heard the practical is going to be on Tuesday.
Yes. The practical for you will begin at 2 o'clock and be open till 6. We have a couple students that are going to start a little earlier, but 90% of you guys will be starting at 2, and you'll have 4 hours, that block, to take the practical.
Okay, so when you start taking it, is there like a time limit once you start taking it?
Yeah, I think you guys have a 90-minute time limit. I think I wrote that in an email. Now remember, this is going to be a 60-point practical, and most of the questions, most of the questions are, I think, 2 points apiece. Yeah, somewhere in the 1 to 2 point apiece area. So you're not going to have 60 questions. And it's evenly spread out between those various exercises that we have done since the first practical. So it's basically 11 through 18, exercises 11 through 18. So you want to go back, of course, if you haven't, and look in the syllabus schedule. It's all there.
Okay. Is this open book, open note?
Well, I can't really stand over you and see what you're doing, can I?
Yeah, but will it be all on the honor system here?
Ethics.
That's an excellent question, and one that I debate with my colleagues all the time. One would hope, but the reality is probably, let's just be real. People probably are referring to their notes and their book and their lab book, and I mean, I can't stop that. I'm not advocating that you do that, but I can't be there to watch you, so I guess it is a moral stand you take as to how you do it.
Can I ask a question back on the respiratory system?
Sure.
The receptors and the chemoreceptors, is there certain ones that we need to memorize better than others, or are they all about equal?
Well, we just spent quite a bit of time talking about that. Were you here for that?
I think I came in the middle of it.
Well, I would say I'm taping this. Why don't you go back and re-watch that segment rather than spend time rehashing what we just talked about. I'm not trying to not answer your question, but we went into that in quite a bit of detail.
Okay.
So that would be my suggestion. And if it's still unclear, send me an email. And by the way, if you guys ever want to get together one-on-one, I can do that too. If you have a specific question you want to cover.
Okay. Yeah, like I wrote down, when I was watching the video, I wrote down, I think all of them in my notebook. But I didn't know if there was like certain ones we just need to like memorize better or not.
There's 2. There's the central and the peripheral chemoreceptors, right? There's just the 2.
And then there's the mechanoreceptor or something
Okay,
like that.
Those aren't chemoreceptors though.
No,
I thought you were
that's-
specifically asking about chemoreceptors.
Just receptors in general.
Okay, so we did not talk about mechanoreceptors, which are sensitive to stretch. So let's go to that section here. Okay. So these particular receptors are housed, as it mentions here, not only in the alveoli, but also in the bronchioles, the small little half-millimeter passageways that lead ultimately to the alveoli, right? And visceral pleura, remember, is the membrane that surrounds the lungs themselves, on the surface of the lungs. So when you take an inhalation, you stretch those mechanoreceptors. Every time you inhale air, you're stretching lung tissue, right? Think about it. The lungs get bigger, don't they? And what that does is it stimulates these mechanoreceptors, and they will begin to send impulses up toward the respiratory centers, medulla and pons, mostly medulla. And what they basically do is they prevent the lungs from overinflating, because that will tell the respiratory center when it goes to send motor impulses down the phrenic nerves to the diaphragm, for example, or external intercostals, we don't want to have too much stimulation whereby the lungs overinflate, and it never happens because of this particular reflex. If we didn't have the mechanoreceptors picking up on that initial stretch upon inhalation, if we didn't have that happen, the lungs would not know. It would just result in more increased muscle contraction, thus potentially causing damage to the lungs. So this is a methodology, a physiology that guarantees that the lungs don't overinflate. Called the Herring-Brewer reflex or inflation reflex.
So could you potentially overbreathe and overstretch and like explode a lung?
No, you can't because of this reflex. So somehow
Hypothetically?
during evolutionary processes in animals with lungs, this reflex was developed. I mean, I can't speak to exactly in what animal or how far back, but this is an evolutionary process that is built into our physiology.
I was thinking about that in terms of the tonsils too, and how you had mentioned how we were removing them.
Yeah.
A few decades ago, much more than we do now.
Mhm.
The tonsil, when you're thinking of evolutionary perspective,
Yeah.
why would they get so inflamed to a point where you can't breathe?
Yeah.
Isn't that? Or why would you think that is? Is it because the infection's so bad that, or your immune system is overreacting towards something that it's causing that inflammation? Or
Well, a better question might be, why are the tonsils positioned where they are?
right? Yes. Yeah.
And why aren't they in the armpit?
Right.
I mean, why put them in a place which is going to be subjected to potential infectious agents, right? When you're inhaling air, that's where you get a lot of bugs. But maybe that's why they're there too. If that's where the pathogen initially comes in, it may stimulate the lymphatic system to begin taking steps to combat that infectious agent. So, it's interesting as you kind of talk through or think about this process. I've read where the appendix, for example, which is on the cecum, you all know where that is? This finger length piece of tissue is also lymphatic tissue. And I've read where some scientists think it'll just be a matter of time before that becomes a vestigial structure where it just eventually goes away in the human race. I don't know if that's true or not, but if it becomes a real problem in terms of appendicitis attacks, maybe over time we'll lose that. I don't know.
That's interesting.
It is interesting to think about.
I thought it was an important part though, like how this is like important bacteria or something.
Well, it does have a role to play, that's true, in inoculating the body upon, say, chronic diarrhea, where you've lost your gut microflora has been thrown off because of the diarrhea. There is some function of helping to reinoculate, that's true. I was going to say that, but I didn't want to muddy the waters. We talk about that in microbiology a little bit too, yeah. So it's not just lymphatic, it also has a bit of a digestive function in the sense of re-inoculating the system. At least that's what I've read. Other
I
topics.
had a question about what like pneumonia does to the lungs. I didn't get to reading that in the book, but I was wondering if you could explain it a little bit.
Where did you come up with ammonia?
Pneumonia.
Oh, pneumonia.
Yeah.
Well, pneumonia is typically caused by a bacterial or viral infection. And there's different kinds of pneumonia. Now, they talk about pneumonia in general there in the clinical application box on 758. But basically, it's impairing the ability of the lungs to gather enough air and ultimately charge the blood with adequate oxygen. So you're impacting the function of the alveoli ultimately, as do other types of respiratory problems too. You can get inflammation, you can get swelling of the alveoli, and there can be fluid that sometimes develops. You know, you've heard of somebody having an X-ray, for example, and they see fluid build up in the lungs. That can be indication of a bacterial infection, or in the case of what we're seeing now, of course, the COVID-19 virus. And you know, Lauren was asking about that earlier, and I told her that I would do some research and put together a little, maybe a voiceover PowerPoint or something about that. But it ultimately boils down to influencing the function of the alveoli.
Is the fluid extra surfactant?
No, it would probably be fluid that moves out of the capillaries into the surrounding extracellular fluid. Yeah, it's not coming from the alveoli. It's coming from the blood, coming from the capillaries. Yeah. The surfactant that the lungs secrete, you don't need much to help with that reduction in surface area so the alveoli can reinflate with each inhalation. So no, that's not too much surfactant.
After you recover from pneumonia, is there scar tissue?
You know, I think there can be. Again, I'd have to do some reading and research on that, but yeah, I would not be surprised if you can have scar tissue, depending upon the extent of the pneumonia, the age of the patient, the infectious agent that caused it. There could be a lot of underlying reasons as to, you know, what could lead to long-term impacts. It is interesting to hear about how fast the COVID-19 appears to hit people. You know, not everyone gets as sick as others, right? But as I said earlier, you go in with a fever, cough, and then in less than a week you're dead. It's a very rapid, for some people, progression. Yeah, it's pretty scary stuff.
You know, they're suggesting that if you're going to take any over-the-counter pain medication, that they say that to take Tylenol.
Yeah.
Over ibuprofen.
Yeah.
Do you know why that is, or do you know what could be the reason?
My wife is telling me that has been debunked. The CDC no longer believes that ibuprofen is bad for you.
Okay.
You know, when these things came out a week or two ago, I kind of thought to myself, gee, where'd that come from? I didn't do any reading or research on it, because there's a lot of things that come out in the news every day that you kind of shake your head at. You know?
Mhm.
So what do you believe? What do you not believe? What I believe is what I hear from Anthony Fauci during the daily news conferences with the president. He's the guy that I listen to, and I listen to nobody else standing up there, to be quite honest.
Mhm.
He knows what he's talking about. And he's the guy, and also the woman physician, I can't think of her name. And do you guys know what I'm talking about? The daily news briefing that the president has, at least it's been daily the last week or two. Turn on any channel at 5 o'clock, I think it is, isn't it, Wendy?
Sometimes it's noon hour.
Oh, maybe it's noon hour sometimes, but I think as a daily, update, that seems to be, at least in the last week, the president's been providing, and Anthony Fauci is kind of the head guy here with regard to the COVID-19. He's, I forget his official title, infectious disease expert.
Back to the lab practical. That's tomorrow. Is
Yep.
there any chapter specifically that you think that we should really focus on as well? I mean, obviously all of them, but that you think that would probably be a bit more difficult than the rest?
Well, I think you should definitely go back and look over the bone structures.
Structures.
And for the Wednesday group, I don't know how many of you guys are in Wednesday and how many of you are in Monday. I just don't know. Well, let me just ask. How many people have been through just the first part of exercises 14 through 17? In other words, just the skull.
I think I have.
So we didn't, are you in the Monday group or the Wednesday group?
Oh no, we did 18 too, actually, joint and structure and movement. So I'm in the Wednesday.
Okay, so in other words, how many of you did not see the knee replacement video? Let me just ask that question. That's easier.
Yeah. Mhm.
All of you have seen it?
I've seen it.
Okay. So I'm trying to remember now. Did the Monday group, you did not see the video? Any Monday group people here? You're all on Wednesday. Okay. Well, the Monday group, I don't think we ended up getting to 15, 16, and 17 in lab. I think that was the Wednesday we were told to go home. I'm trying to remember. My weeks are so messed up. It seems like I've been doing this online stuff for 6 months. It's only been 2 weeks or less. But anyway, back to your question. If you go to that handout that we used, we meticulously went through all the bones. We talked about the processes in the fossae and the meatus, all those different structures. You do want to go back and review those. So that's basically 14, 15, 16, 17. Those are the 4 exercises that related to axial and appendicular skeletal structures. And that's a big chunk of this practical. So that's a big part of what you should be studying. That doesn't mean blow off integumentary system at all. It doesn't mean blowing off basic organization of the skeleton, exercise 13. But the majority of the questions will relate to 14 through 17. By the majority, I mean more than 50%. I'm not asking any questions on the replacement video, knee replacement, because the Monday group didn't watch it. But nonetheless, exercise 18 on joint structure and movements, that is something to definitely go in and review and be familiar with the basic parts of the knee joint and re-familiarize yourself, review the movements of the joints. We talked about adduction, abduction, extension, flexion, those terms. don't forget the answers to the lab report questions in the back of each exercise is a lab report. Those I posted in Blackboard. Those are all there. So you can check your answers if you do answer those questions. So I would just carefully go through, 11 through 18 and focus a lot on the bones, the structures of the bones. Obviously, I can't use actual bones. They're going to be diagrams, perhaps, or descriptions of structures. Like what bone articulates with what bone. I'm not sure if that answered your question or not, but
Yes, it did.
Sorry I had to leave last time on the Zoom meeting, but I had an exam. I
yeah,
had to,
I heard
Um,
you did. I heard you had to
yeah,
leave because
but
of
I was
the
able
exam.
to watch the Zoom meeting afterwards.
Well, good, because I felt bad. You had asked a question. I forget what it was, but and I wasn't able to get to it. And then I looked and you were gone. And then somebody said, "Oh, he had a test or something in another class."
Yep. But yeah, thanks for answering the question. I saw it when you posted on Blackboard.
So some of you have gone back and looked at the Zoom meeting recordings.
Yep.
Well, it's all there. So these Zoom meetings are there in case anybody wants to look at them. I was telling some of the group at the beginning of class today that I've been able to go into Zoom and I'm beginning to learn how to look at the data and see who's going in and looking at this stuff. And I was a little dismayed at the lack of what I perceived as students utilizing the voiceover PowerPoints and so forth. This is the best thing to be looking at. Look through these chapters, because unlike class where we have a formal lecture, we're utilizing these Zoom meetings more of a review session, I guess. I'm hoping you've gone in, started to read the chapter, you've started to look at the voiceover PowerPoints, and you're learning it that way.
I'm subscribed to your YouTube channel as well. Do you plan on keeping that up
Oh yeah.
for the rest of the semesters?
Oh, I'm sure.
Yeah.
It's funny you mentioned that, because when I first started doing these PowerPoints, somebody subscribed and I'm like, oh my God, that's pretty amazing. And I don't know who the person was. She looked like she was a college student from who knows where. And I'm like, oh, that's kind of cool. This was not my plan, believe me. This is the last thing I thought I'd be doing, 2 months ago. But I think in the long run, maybe it'll be good.
Mm-hmm.
Yeah. But I was telling our IT guru this morning, after I do one of these voiceover PowerPoints, say a 15 or 20 minute lesson, I'm done with that and I just crash. I'm so physically and mentally spent. I don't know what it is, but I am totally exhausted after I do one. Maybe because I want to make sure I don't forget something, or I hope I explained it adequately, and I can't go back and edit it. That's the thing. I can't even go back a slide. The system won't let me do that. So I end up hitting a button accidentally, and I can't go back unless I start from the beginning. And if I've already talked for 20 minutes, I'm not going to start from the beginning.
Mm-hmm.
There's little things you learn as you go through this, I guess. But I do understand how difficult this is for you guys. It's just not optimal. In your other classes that you have, are the instructors doing Zoom meetings? Are they providing any sort of voice over PowerPoints? How are they helping you with the material?
Luckily, my other class is online as well. So
Okay.
Thankfully the format was already, online, everything. So not too much. We had a project that involved doing, job shadowing. And so that's been obviously canceled. But other than that, not too much for me. I don't know about other courses.
I had one teacher which I really like. He actually on the sidebar of the Blackboard, like where you have the plans and PowerPoint stuff and all that, he put in each week he put in a slide and he put like a snapshot of the syllabus for that week into it.
Oh.
So there's like an individual spot to click on for each individual week, and then he has the plans in there for that week.
So Melissa, was this, I'm not exactly sure where you're describing his location of where you put this.
Like that's just a minute. Sorry. Yeah, look at it myself to kind of explain it. Over on the left side when you go into the class.
Yeah.
It's that bar, like you have the announcements and Zoom and content.
Oh, yeah.
It's that bar there. And there's like each individual week that he has like a picture of the syllabus, like the plan. And then he has some other stuff that he adds into, like instructions and all that.
Yeah, okay. I understand what you're saying. So oh, come on. I'm just trying to see if I can, so you found that very, very helpful.
Yeah, because you can just see exactly what you need to do for that week instead of getting mixed up with anything else that might be in with it.
Yeah. Boy, I'm just having a heck of a time sharing. How do I get to my... Okay, do you guys see Blackboard here or not?
Yeah.
Okay.
Yes.
All right. So, so you can still see it?
Mm-hmm.
So he puts it over here somewhere.
Yeah.
What does he call it?
He just has like the week of with the dates. So it's like
Gotcha.
the week of the 22nd to the 28th.
I understand. Okay. And then you click on that and it gives you what you're doing that week.
Yeah.
Well, if you guys think that would be helpful, I can certainly do something like that. I mean, the other thing that I guess I was assuming, and you know what happens when you assume things, is that you would just look at the revised lecture schedule, and there's the week by week. I know you can't see it here, but it's on the syllabus.
Yeah, that's what I've been doing for you.
No, I mean, I think that's an interesting idea. At least people are going to probably more likely click there than go to their syllabus. Or just put a link to it right there. That might be another thing too.
Yeah.
Okay, great. Okay, so you feel like you're getting adequate support from your instructors? It's kind of a loaded question, I guess, but.
Yeah, so far.
Mm-hmm.
My math class has been pretty much non-existent since March 19th.
And what are you taking, Joseph? Calc 1 or what?
Calc 2.
Oh, Calc 2.
And the teacher's just been kind of resorting to giving us YouTube videos from all over the place until she can figure out how to make something work. And she's the youngest of all my. She would be good at technology.
Yeah. Who's teaching that?
I think her name's Connie Funk. She's in Jamestown.
Okay, must be an adjunct part-timer. Yeah. Boy, in Calc 2, that's a hard thing to teach. Hard thing to learn, I should say. Yeah. There's probably only 3 or 4 of you in Olean doing it, huh?
Yeah, just 4 of us actually.
Yeah. Lauren, were you going to say something?
No, I wasn't gonna. Khan Academy, but I was gonna suggest that, but they only have pre-calculus on there.
Uh-huh.
Or actually, they do have calculus on Khan Academy too, not just pre-calculus. So that's a resource if you haven't already checked it out.
Mm-hmm.
Yeah, look at it.
If
I
you need
think-
it.
Didn't I also put some stuff here for you
Thanks.
guys? Oh, no, I'm gonna not be able to find it here. Oh yeah, this link has a bunch of A&P videos.
Mhm.
So I think he goes through each of the systems. Well, maybe I'm mixing it up with microbiology, the other course I'm teaching too. No, that was the one that he goes through there's different models. That's what it was. He goes through models, he goes through bones, I think.
Mhm.
Yeah,
I-
I'm thinking of a different class now.
You attached a link to one of your slides for the neuromuscular junction from Khan Academy.
Okay, yes. Uh-huh. Yeah, Khan Academy is pretty amazing. They got some good stuff there.
Yeah.
Mhm. Let's see. Don't forget, here's some unlabeled base diagrams here. Chapter 7 is bone. So if you're looking for practice in labeling, there's a whole slug of unlabeled diagrams here. I'm just randomly clicking, but you can see where I'm getting. This is the same diagrams that are in your lab book. You know, if you want to practice labeling, these are good. So, any other topics in muscular or respiratory? Any lab stuff?
Where are the answers located on Blackboard
Okay,
for the lab book?
yep, if you go to stuff to copy and bring to lab, do you see it on the screen?
Mm-hmm.
And then I've put at the top here, answers to lab report questions from
Okay.
lab manual.
Yeah, I taken photos of the red folders that you had in the lab room
Uh-huh.
with the answers, and so
Oh.
thankfully I had that for the chapters that we're going to go over for the lab practical. But beyond that, I didn't. So that's helpful.
Yeah, so this has got all the answers to all of the remaining exercises. Yep. I thought maybe if anybody's using those, obviously you are, Lauren. I wanted to make sure that they were available to you. So I had asked our lab tech, Deb, to photocopy those last week, and she kindly did. And
Okay.
so that's where those came from. And then once we get back from break, in lab, we'll be doing muscles. And we'll unfortunately won't have the torso, arm, or leg model to use to learn the muscles. We'll have to learn them on diagrams. But anyway, we'll talk more about that after we come back from the break. But if people want to get a jump on it, maybe I'll send an email out to everybody today or tomorrow or Wednesday and just say, hey, when we come back from break, we're going to be doing this. If you want to look ahead, here's what you can look at.
Mhm.
Okay, last call on lecture or lab topics. Okay, well, have a good break as best you can, and we'll have the answers to the lab practical available for you to look at on Wednesday. So if you're wondering when can I check my practical, see what I got right or wrong or whatever, I've got Blackboard set up such that you should be able to go in on Wednesday. I think starting at, oh gosh, I forget what time I started it up. I think 10 o'clock. Sometime Wednesday, anyway. You'll have access to your practical.
And when we submit the lab practical, will it automatically grade it as well?
I think so.
Okay.
And then I will have to look over that, but I'm pretty sure you will have both access to the answer key and you'll be able to see your score 24 hours from the time you take the practical. That's how I think I set up the system.
Okay.
So by the end of the day, Wednesday, let's just say late afternoon, you should have access to it. If you don't let me know, I'll remedy that. I'm still learning how to set some of these parameters, and it's I'm not perfect, but I certainly will try my best. Okay, anything else? Do you like my background?
Yes.
Do you know where I am?
Is that your backyard?
Close.
Just kidding.
This is the Conewango Swamp just outside of Randolph. I went down last week and I took some pictures.
Oh, nice.
Yeah.
Beautiful.
I tried to get to Kremlin, but I couldn't get it loaded quick enough. I like your dog there too. That's cool.
Thank you.
What's his name or her name?
He's a boy, Cooper. He's a
Cooper.
boy. Yeah. Yeah, he's a big baby.
That's a beautiful photograph.
Thank you.
Is it a what? What's the breed?
I think so. He's like a mix. He's an Australian Shepherd, but also Border Collie too,
Oh.
and probably something else. But yeah,
Uh-huh.
his ears are they're pretty big in that picture and in real life. So he has giant ears.
He hears very well.
Yes, he does, but he doesn't listen to me.
All right. Well, I will let you guys go then. Have an enjoyable break as best you can. Stay safe and do get outside and enjoy because we'll get some warm weather here soon.
Okay, you too. Thank
Okay.
you.
Thanks. See ya.
Bye.